Starting in a few minutes. Starting in a few minutes. Oh, people are here already. People are here. What's going on? I am in Japan now. I'm no longer in China. I'll be in Japan for, I think, about 5 more days. All right, we'll give people a few more minutes to get here. Any off-topic questions while we're waiting for people? Thoughts on Windows 10? I think that Windows 10 almost entirely consists of things I don't want and don't care about, and they're destabilizing what good things they had. And I think if the Linux people were able to organize themselves efficiently, they should have, actually way back when Windows 8 happened, Linux should have been able to take over from Windows, but they can't. Just open source people don't know how to muster a product in that way, so it'll just never happen. Like Microsoft did everything they could to kill Windows, and the Linux people still couldn't take it. So, you know, at least they have phones. At least they have Android phones. We found nearly 100 bugs in GCC and 6 bugs in the Rust compiler since yesterday with your compiler fuzzer. Yeah, we're going to do a fuzzer too, I think, at some point. We're not yet at the point where we need a fuzzer because we still have bugs that we don't need a fuzzer to find. But, you know, at some point that'll be a very good tactic for testing things out. Am I meeting with Sony about a new game while in Japan? Not that I know of. You never know what meetings could happen. Have I been following Bitwise at all? I don't know what that is. What are my thoughts on English Country Tune? You know, I liked playing it. It has some upsides. It has some downsides. It's not as clear and strong a game as Steven Sausage Roll is. So I think Steven Sausage Roll is by far the better game out of those two. But if you want to play something, English Country Tune could be a thing you play. Why do I think C++ is more preferred over C for system level, even though C++ has more features? I'm not sure I understand the question. Wouldn't people prefer something that has more features unless those features came with a price they were unwilling to pay? Wow, a lot of people are here. I'm surprised because I haven't streamed in a while. It's great to see so many people here. How did we handle different resolutions in Braid? Upscaling textures with nearest filtering applied causes artifacts within the texture for you. What kind of artifacts do you mean? Do you mean just blurring out sharp lines? Because that's an obvious thing that'll happen if if you stretch a texture, you're obviously going to blur lines. Um, but we didn't really have sharp lines in the braid art style, except for the characters and stuff. We did a weird thing, uh, especially for the main character, where we round him to the nearest pixel when we draw. But the backgrounds don't, well, and the foregrounds of the levels don't have that applied. It's only applied to a small number of things. And even that was not so good. It makes motion look a little bit more jittery, but I preferred that to having blurry looking characters. Does the Twitch TOS not let me tell people where I am? What? Try Bunsen Lab Linux. It is the continuation of Crunchbang Linux. I've not ever heard of either of those. I don't want more Linux distros. There's already way too many Linux distros. Yeah. You thought you saw me near Aoyama. Isn't that in Tokyo? I'm not in Tokyo. Twitch TOS is crazy. What advice would I give to someone who's been programming for a few years and wants to get into game engine programming? Is Casey's series a good jumping off point? Casey's series might be a good way to get some context or something, but it's really long, right? There's like 500 episodes or 450 or something. And so, like, I think it's more useful about following a big project and seeing the kinds of things that have to happen. Like if you want to, like I think I don't know. I really don't know. It depends on what you want to do. Sometimes it could be good to take something small and tractable, because the thing is, if you start doing Handmade Hero, that's a commitment. And you're either in that for a really long time or you give up. Whereas if you pick a small project that seems like a low-level programming thing and do that, it could be something you do in just a week or a couple weeks or something. But I don't know. I don't have a concrete suggestion. Someone asked the C++ question again in the same words. I already answered that. Yeah, almost 1,000 hours on Handmade Hero. That's a lot of hours. It's, wait, really 1,000 hours? So at 40 hours a week, if you watch Handmade Hero as full-time job, it'll take you 25 weeks. It's a long time. Oh yeah, Bitwise is Paris stream. I see. Yeah, that seems like a cool idea to me. I haven't seen it at all. I heard when he was going to start that, and I thought it was a cool idea. But since then, I've just been really busy working and stuff and traveling, and I haven't had a chance to look at it. Where am I on the camera? How am I doing? Okay, we're good. Have I tried 4Coder? No, because I just don't feel like I have the time to switch editors right now. My general plan is to switch from Emacs to 4Coder or something else, but 4Coder seems to be the leading candidate, but not yet because I've just got too many things going on. Oh, okay, you're talking about round to nearest on a texture. Yeah, some lines will definitely jump to the next pixel while others won't, for sure. That's why you so don't use round to nearest with a scaled texture. It's going to look terrible. You either have to do bilinear. Sorry, my brain thought bilinear when I read round to nearest. You have to either do bilinear or you have to draw the texture at a fixed scale. Now you can do a higher level. Okay, so graphics cards do this bilinear filtering, but you can actually do a higher quality sampling than that. GPUs don't have higher quality sampling built in usually because it's slower, but you can make a shader that does a good quality signal reconstruction, and so it won't quite feel as blurry, but at some point it is what it is. I am on hotel Wi-Fi right now, so if the quality is fluctuating a lot, I'm sorry. I did see that Aubrey de Grey proved something. I didn't look into the details of what it was. Okay, so Guitar Freak says, surprised to hear me say, if someone tells you you're wasting your time playing video games, don't listen to them. Isn't that a little strong of a statement knowing how addicting video games could be? A lot of games really try to take your time away. Well, that's not what I said. I didn't say if someone tells you you're wasting your time with playing video games, don't listen to them. I said, at least I think I said, I meant to say, don't let people tell you that video games are a waste of time, right? And by that I mean games as a whole, as an entire subject. Someone could certainly be wasting their life playing, Farmville, or I don't know, like whatever Zynga game, or whatever, Puzzle and Dragons or whatever. There's plenty of that stuff. And if the speech were longer, I probably could go into that. But it's not my intention. In fact, I gave a little mobile game dig there when I said that. Have I seen Rot Sprite rotating pixel art? Huh. For coders, very C, C++ focused. Have I talked with Alan Webster? I haven't. But the thing that you would do is, you could program something like that in any language as long as that language can generate a dynamic library, and then you just call into that. So I'm not that worried about it. I am going to make some more tea, and then we'll start. Did I give some kind of talk at the indie conference thing in China? Yeah, and they already put it on the internet, and you can watch it. I don't have the link handy, but someone probably does. Well, let's get started. So one of the things I did when I was traveling was I cranked through a bunch of compiler bugs and fixed them. And now it's time to start doing some optimizations and whatever as a change of pace. And whenever that time comes, I sort of think to what are the things that have been bugging me for a long time, and I like to kind of nail those. And I've actually, in addition to fixing a bunch of bugs, I've done a couple of very basic fundamental compiler restructures, internal restructures, to make it better and stronger and faster and all that. And there'll be more such things going on. And in fact, maybe this week in Japan here, I'll do. There's a significant restructuring that I'm thinking of undertaking, but that's not the subject of what I want to do right now. What I want to do right now is one of the steps that I've been thinking about that would reduce the number of bytecode instructions generated by the compiler for any given sequence of code. And there's a few reasons why that's important. One of them is it makes the compiler faster, right? As long as you output fewer instructions and you don't spend very much time figuring out how to output fewer instructions, then first of all, you know, when things are running in the interpreter, like compile time, they'll run faster. But also, you know, if you output a bunch of instructions that are unnecessary, and then you rely on the back end, well, also, okay, so then obviously, uh, you know, if the code you generate is running too many instructions, that's going to be slow. But usually, hopefully, if you're outputting to a backend like the LLVM optimizing backend, then hopefully most of those instructions go away. They may not always go away, which is why it's a good idea not to generate them in the first place. But also, LLVM will spend a long time, or a substantial amount of time, just making those instructions go away, right? So you spent time generating them and then time removing them. And why not just not spend any of that time and have a faster compile time altogether? And then similarly, for our x64 backend, which is currently not optimizing at all, and even in the future when it does optimize, we want to think about, you know, what happens if people want to build as fast as possible to have a fast turnaround loop. Then in that backend, we would like the debug output to be as fast as we can, right? Without doing anything crazy, right? So if it generates code that's way too many instructions and is requiring an optimizing backend to get rid of those, then that makes the distance between debug build and release build much further, right? And we don't want that. We want the debug build to be closer to release build. So there's a bunch of things that we can do to fix that, I think. Actually, I'm going to get a little, I'm sitting in a hotel right now. I'm going to get a hotel notepad and I'm going to start writing down some of the things that I maybe want to do. This is a little bit of a sidetrack, but as I'm talking to you, things are popping in the head, into my head. So there's array bounds checking probably generates a substantial amount of instructions because of the way we do it. Because when we do compares like that, we generate branch instructions, and they might be more verbose than what we need. I don't know. It's something to think about. And because I didn't have the piece of paper out, something else popped into my head and then popped out of my head. But let me talk about the thing I'm going to do today. Or try to do. We'll see if we're successful. Sometimes the compiler is complicated enough that sometimes when I try to do something, I'm not successful, but then we sort of learn. Anyway, so when you have an if statement, like if x, or if, I don't know, let's do something simple. So, like I often like doing an if statement without a conditional. So I have like an x is a pointer to void, right, or something, or let's say it's a pointer to a data structure, like a pointer to an entity. We have those all over the place. And we have some code, and I might just say if x, right, and this is a C style thing where we just say, look, if x is null, then this is false, otherwise it's true, right? Now, when you do this, what happens is, first of all, the if statement says, I want my conditional to be of type bool, right? Oh, the thing inside here is not a Boolean. Let's cast it to Boolean, right? So there's sort of this implicit cast, not to ball, cast to bool. So this cast gets inserted silently by the compiler, right? And, well, that doesn't seem so bad, right? But the thing is, bool is a very specific type, right? It has two possible values, 0 for false and 1 for true. So if you cast a cast to bool, so you just say something like, is x equal to 0, right? Yes, jump B, or A, well, the jumps are going to come out in the wrong order. Write 1 into result, jump B, A is write 0 into result, jump C, and then B, right? That's not terrible, I guess. And B is like whatever comes next, right? So anytime you cast something to bool, it's like, and this equal to 0 is like a little bit oversimplified because it depends on what the type is and all that, right? But for a pointer, it's 64-bit 0, right? This is the sequence of things that we would do. Now the problem is, because this is a cast to bool, we're inserting all this stuff. You know, this is like 1, 2, 3, 4, 5 instructions, right? And that goes into here. But the if is basically, an if else is basically doing this same thing, right? An if else so is condition equal to 8-bit 0, yes, jump A, do then block, jump B, A, do else block, B, right? Is that right? You know, the exactly what these instructions are can vary, right? Okay, so, well, what that means is, let's call these something else, C and D, right? And of course, this then block can be an arbitrarily long sequence, and so can the else block. Now the problem is, well, here's what it looks like for basically every if where the condition isn't already a bool. It's you just jam those together, right? We'll call this result. So we just end up generating the sequence of instructions, and like, okay, we just wrote 0 and now we're comparing it. But furthermore, we've got this if compare branch and then if compare branch. So like every one of these ifs is really two frickin' things of the same thing. It's like crazy, right? Do you guys get what I'm saying? It's undesirable. I don't know how much I want to try to explain this. Let me know if this makes any sense at all, what I'm talking about. Ginger Bill is saying, why not just allow for multiple-sized Booleans? Well, I haven't gotten to the solution that I'm about to do yet. Yeah, okay, so Ginger Bill obviously gets it, and Prognostic says it makes sense. Okay, so as Ginger Bill says, one of the things that I could do is make different Boolean types. I don't think that I want to do that. And the reason is just that I just don't want more types in my type system. That might not be the right decision. It might be better to have all these bool types. But for now, I don't think so. So really what I'm going to do is for the if condition, I'm just going to say, we don't need to cast to a bool strictly. We need to generate, any integer type, essentially, that represents the truth value of this thing. And then this if can know how to operate on that integer type. And that'll get rid of this first set of instructions in most cases about jumping and stuff, right? And it'll leave us only with this second set. Okay, so that'll be good. However, I got an idea. I got an idea for a different stream. Okay. So this is essentially going to get casted to any integer instead of any bool. So anything that's already an integer, it's fine. You know, a pointer is just an 8-byte integer, or a relative pointer is a smaller integer. What else? Oh, a string. If you have a string or an array, those test as truth values. For a string, we just grab the length integer out of the string and then use that. For an array, same thing. We grab the count element out of the array, and that's it. You know, those are most of the types that have truthiness values. So the first step of what I'm going to do is only going to help us in some cases, right? It's going to work if we have an if or we have a while, you know. But the thing is, most ifs already have a condition, right? Most of them are like, if x is less than 5, right? Or if maybe you say this, right? The first step of the optimization I'm about to do won't even catch this, right? Because this already generates a Boolean, right? So then step 2 is going to be about maybe optimizing this down to something, maybe recognizing that it's a comparison against null and that we can just grab this, right? Shouldn't the code gen just be one test instruction followed by a jump based on whether the 0 flag was set? Well, you know, that's basically what this is, except we're not assuming we have a 0 flag because this is a higher level bytecode. So, you know, you get a register result. But yeah, that's basically what this does, right? That's what I'm saying is we're getting rid of this and we're going to just have this for some subset of cases. And then we'll work on expanding that subset of cases. What is null? Null is defined to be 0. It is a 64-bit 0. Okay, so that's the basic idea. And you know, I don't know how far I'm going to get into that today, but that's the thing. Now, I'm going to be running a debug build of the compiler at least sometimes today because that's the one that reports how many instructions are generated. So I compiled Sokoban here, and it's 229,799. And I'm going to write that down because I want to see that number go down at least some as we start to do these optimizations. And then I have a really tiny program here called simple if, which is so small, it's just this, right? Now it says it's 258 instructions. This doesn't take 258 instructions, but most of those instructions are stuff in the preload for the compiler. Like when you start the compiler, we compile a few utility functions that get used by everything else. And that's where that is, right? But this is fast to compile, even though we're running the debug compiler and etc. So first we want to see this number go down, and then when we want to really see our progress, we can see this number go down. But then we also have to make sure that our programs still work. So probably we'll be in the release compiler for a while. Okay, our small program was 258. Okay, so all that makes sense because I'm going to start working, I guess. 230K. No, that's okay. Those are two different numbers. So this 230K is the bytecode instructions. The lines of code, the lines of source code is 74K now, right? It's been in the 70K neighborhood for a while. You know, this is our bytecode pseudo assembly internal representation, right? So there's about 3 instructions per line of source code on average. We'd like to get that average down a little bit. Has it been released to any testers so far? Just internally to our team, we have more people using this. 230K is before LLVM. That's our own instructions. I don't know what LLVM does, and for the purposes of today, I don't really care because, like I said, I want all backends to get this benefit. Okay. Now, I'm hoping, okay, let's switch to building the release compiler maybe. Okay, so in bytecode builder, we have emit code for if, actually no, we want to go to the type checking. Well, let's look at this, right? So we emit the code for the condition, right? So that can be an arbitrarily complex thing. We get a register back, and whoa, hold on. I left a debug instruction in here. Do I have any others? Oh, shit. Okay, this is for LLVM? What? This is not mine. Okay. What the hell? Okay, we're going to have to talk to people about this. So, like, bytecode instructions that are essentially no ops are now this is what happens when people besides me work on things. Bytecode instructions that are essentially no ops are being used to control generation of debug info, and I don't think I like that. Maybe it's fine in principle, but I don't know if I like it. In part because it's going to affect our numbers here. It just blows the numbers up and makes our progress look less good. But maybe it's fine, and maybe when we generate instructions, we just don't count these. I don't know. But for now, we are counting them. So when do these get used? Everywhere. Holy cow. Yeah. I'm going to have to talk to them about what the requirements are and if there's a way we can do it without throwing instructions all over the place. Because I don't totally like that. Anyway, so emit code for if So we use this goTo constant instruction, and I believe, yeah, this will handle any size of value. So this should just work, right? So the real thing that is just the problem is the expression. So now the question is, do I make a new kind of implicit cast that says, oh, we're just casting to, an integer truth type? Or do I say, screw that, the thing in the if, we know we're emitting a condition here, and we just output we know we're emitting a condition. So instead of making a cast in the syntax tree, we just emit the code for that thing here. I'm not sure which is better. Sometimes I make these decisions wrong, and then I regret it, which is why I'm thinking about this so much. If I do it directly in the bytecode, it seems like less fuss, but then I can definitely only use it in contexts like this, where I say I'm doing an if or I'm doing a while. Now, the problem with that is what about Boolean operations? Like if you're saying A, logical and B, logical and C, you would like to be able to propagate this down to all those arguments. How would I do that? See, I have to think ahead of my current implementation into that. It's weird because you would have to notice that you'd have to poke into the tree, first of all, and say, okay, the user, see if you say this, right, X is A and B, that has to be a Boolean for sure, right? But if you say, or maybe it doesn't, I don't know. Maybe this is why Ginger Bill has all these bool types. But for now, we'll say that is a bool. Like, that's not something that people do that often. On the other hand, if you say if A and B this, nobody directly looks at that value. So you know that can be whatever. And furthermore, we have stuff like this. If you want to be able to add other condition optimizations, you want to examine the expression. Ginger Bill says, I'm going to just remove LLVM soon, as I am finding so many bugs. Trying to think I should take my own back end. I've been looking for libraries. Yeah, we've been having some problems with LLVM as well. Yeah. I don't know. Like our long-term plan is to move off it for sure. But, it's useful to us in the short term. All right, I'm getting cold in here, so I'm gonna short tea break while I think about this and turn up the heat in this room. I don't know why it's so cold. Back in a minute. So Jacob Lee is saying, for example, emit condition, expert, true branch, false branch. That doesn't make sense to me exactly with the way that I do things, but I'm not sure exactly what you mean. Here's what I'm thinking is that during the type checking phase, or actually before that, this is tricky. See, because you can do, when you say if A and B and C, this A and B and C turns into some binary tree, right? There's binary operator ands and all that. And you can say, oh, these are inside an if. We're going to walk down that tree and we're going to flag some of these as not needing to be strictly bool. They have an integer result. Well, the problem is I can't really do that at type check time because it's too late. But I can do it in the parser and then also when expressions come back from messaging. Yeah. That seems plausible to me. And then, so how does that answer the question of whether this all happens from byte code or not? Well, if these are flagged as producing an integer result, then, well, for greater than, equals, anything like that, it doesn't matter, because those all generate Booleans no matter what. Unless we do something crazy. We could do something crazy and say, if y is greater than 5, right, that this just returns the register for y if but then we don't have something to return if it's not greater than 5. So that's not really that helpful, unless I'm missing something. It does remove an instruction. No, not really. Not really. I don't know. I need to think about that one more. I don't think there's much we can do about these, but these, I think, are okay. I'm not sure how much this optimization is going to help ultimately if we can't do anything about these. Maybe I shouldn't do this optimization. I don't know. Here's what I'm thinking now. Jacob Lee says, you make conditions only specially handles and or and leaves that can condition code optimized and otherwise falls back to emit expression. I see. Well, I mean, you need two paths, right? You would need the version for this case and the version for this case. But yeah, I agree. That's one way to do it, and that's one of the things I'm thinking about. Okay, no matter what, some code needs to go in the type checker. Because if I get rid of this cast, then like that used to be the thing that made sure that whatever's in here could be converted to bool, right? So there always needs to be some code in the type checker. You know what? I wonder if there's an easy way to measure what the impact of this would be. Is there? So if we go into like Sokoban, I'm just searching for if. So that's a Boolean not, which I guess we could optimize, but it would be one more step. That's another Boolean not. That's a direct test of a bool. That's const expr evaluated. There's a Boolean equals, which for reasons like I said, doesn't really help us unless I'm not thinking of something. There's another equals, equals, static if, those don't count. In these cases, I don't remember what the code gen looks like for those, so think about that later. So this is a pointer. So we're saying if not pointer, which again, I guess we would have to handle unary not, right? By I don't know, handling unary not in a way that doesn't just generate another branch like that seems a little bit bananas. Well, let's talk about a different optimization we could do just to think about our options, right? So here's another thing we could do. If we assume that we're always going to need these casts to bool, right? We're often going to need them anyway, because, you know, greater than, less than, and all that generates them. Then we could, oh, let me go back, way back. Did I really delete all that? So we had, you know, compare you know, so we move 1 into result, jump B, right? A. Right, and then B is whatever comes after this. So instead of doing this, we could put into our bytecode a conditional move instruction, right? Where we do the following. Instead of doing all that, we can say well, there's all sorts of variants on what you could say, right? You could say move X or Y into result based on value 1 or 0. Like, you could pack all of that into an instruction. I don't know if our instructions are big enough to do that. Let me think. Result. I think we could fit that. If our things are no bigger than 32 bits. Which they wouldn't be. I mean, we could make a very special. We could make a special instruction that's like generate Boolean, right? Or cast to Boolean. Result value, right? And then every backend could decide for themselves what is the most efficient sequence of instructions to generate that. What I would like to do is just put in a special hack thing. Was my homepage originally hosted on GeoCities? Not that I know of. Unary not can be done without branches. I know that, but the way that I would do it is by, you know, propagating the information around my code generator so that you just generate For the outer thing that's going to branch, you just change your branch condition, right? That's what you really want to do. You don't want to generate any instructions at all. It's just that can get annoying too, and I'm not sure I want to buy into that level of complication right now. For x64, don't you want to be generating C moves anyway? Possibly. I don't actually know what is the best policy. Fabian told me that explicitly branching is better than C move in some cases, but I don't know what those cases are. Right now, we explicitly branch, and it's a lot of instructions. I think the problem is a conflation of cast to bool with zero test. The if doesn't care if your pointer is 0 or 1, just with 0 non-zeros, forcing 0 1 in the first place is redundant. Yes, that is exactly the problem that I started out with. But what I'm saying is I'm not convinced that that is going to help in the majority of cases. So here's the thing. What I really should do, because premature optimization is the root of blah, 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 what I really should do is implement in the profile, in the bytecode generator, a debug mode that basically makes a histogram of where all the instructions come from. And then we could actually see which instructions take up most of the program. You know what? We're going to do that. So, because I don't really know which of these has the most impact and how much has the most impact, I'm sort of leaning toward implementing this because, like we said, we could put a C move in the back end or something that does this. So I'm leaning toward that, and then once that's in there, then doing the version that handles, integers of arbitrary size, which I feel like would have less impact across the program than this, but once this is gone, would be significant. But I just want to know, oh, do you guys want to know something else crazy about all this? So like right now in the backends, this thing here, this test for equality, also generates one of these branch sequences, right? Because we're outputting that equality value into a frickin' register, a value register. Actually, not always. Not in the if statement case, but there are some cases in which it does. Okay, let's do that. Let's do the profiler thing because I think that's the smart thing to do. We've had a discussion here. It's been interesting, and now let's be smart. So I have stuff like if underscore debug, I record the line number and stuff. And these fields don't exist if we're not in a debug build of the compiler. So, because we emit a lot of instructions, as you saw, we emit 230,000 instructions when we're compiling Sokoban. So, we wouldn't want to take a little bit of extra time there if we don't have to. I'm going to say screw it. Screw it. We're going to make a thing called histogram. And how's this going to work? I guess we have a hash table, but it's going to be a really made up hash table because we don't have a generic hash table that takes integer arguments. But we're going to take the line number. So all bytecode instructions are generated in this file, first of all. It's a 7,000 line file. One advantage to that approach is that the line number uniquely identifies which instruction it is. And so we can make a little table of dudes. No, you know what? You know what we do? Screw a hash table. Screw a hash table. We just make a 20,000 entry table, which means our file can be up to 20,000 lines long. And we just drop things in there. Yeah, okay, this is what we're doing. Assert debug. What do I call this? Debug generation table size. That's going to be a constant. Is greater than line number. We're going to say debug generation line numbers. No, not line numbers. Debug generation count subline number equals, or no, plus, because we're in C++. And then debug generation that's it. That's how we're going to do it first. Now we'll record which instruction it is. Debug generation instruction line number ins should always be the same for a given line number. So this is just going to be there so that we can, you know, for kids, so that we can have a human readable, like, what was this instruction? This will tell us what the instruction is, but we have to jump around in the source file for every time. Whereas this will tell us, you know, really what, just in a nice table, we'll see instruction type and line number. That's what I'm trying to say. Okay, so const int debug generation table size equals 30,000. Why not? We'll be generous. Okay, if debug and if int debug generation count. Now, because these are in global storage here, this is guaranteed to be initialized to 0. That's in the semantics of C++, so we don't need to initialize it. Okay, let's just see if that compiles. Oh, well, first of all, release doesn't have this stuff in it, so that's not helping. I have to look on my phone for chat because I'm traveling. I don't have a second monitor. Yeah, so what I heard, you know, what Fabian was saying was, you know, cmove is often not good for the branch predictor. But I don't know in which cases that really matters. Like, I think he was saying, well, look, if the code you were going to skip over is very short anyway, you know, it doesn't really cost you anything to speculatively evaluate both branches. So for something like that cast to bool, you know, if you have one constant value and another constant value, like, that's probably much better as a cmove, because, yeah, I don't know, but I haven't thought about it. I don't know much about what really costs electrons at the CPU level. Okay, so let's build a debug build, make sure that compiles. Okay. Okay, so now in main, we're going to say, is this in debug? Yeah, okay. It was right there. I missed it. So here we're going to say print yeah. This is going to be here, there, and then we'll just throw this at the bottom of this file. And here's what we're going to do. We're going to have a thing called, because we're going to want to queue sort this puppies. We're going to say long name, whatever, so sue me. Int line number, int count, bytecode, instruction. So here's what we're going to do. We're going to say array instruction frequency info infos. I don't know. Array reserve or programming language infos.reserve. I don't frickin' know. 200. This is just to prevent us from spamming the array. It doesn't matter. Okay, so for int I equals 0, I is less than this thing. Oh, this all has to be in debug, by the way. So if auto count is debug generation count sub I, if there's nothing there, continue. So if that line of code in the source file didn't generate an instruction, then continue. Otherwise, we say instruction frequency info.count equals count, info.line number equals I, info.instruction equals debug generation instruction sub I, and infos.add info. Now, every time I queue sort, I just copy it from somewhere because I never remember the order of arguments. So queue sort infos.data, infos.items, which is the number of items, size of infos.data 0, and then compare instruction infos. And then this is the annoying part. The compare routine. Just do this. We're going to compare instruction infos, and instead of double pointer, it'll be single. And we turn AP count, is that right? That'll give us low to high. We want high to low. I always get it backward. Whatever. We're just programming. Syntax error. C++ needs the parentheses. There. Okay. Well, maybe that's all going to do something. Let's see. Oh, well, we didn't print out the results. Okay, 4. Printf. Let's say %7d %s for the name, and then that's it. Oh, the line number. So the count is going first, and then the line number is going third. So info count, info line number is third, and name, yeah. Bytecode names sub info instruction. It's not called count, it's called items. The array in the language is called count. The array here has a thing called items. All right. Let's see what happens there. Didn't print anything. Okay. Now what's worrying me is, oh, nothing's really worrying me. Print instruction use, instructions generated, printf. Now, I sort of feel like we're doing something wrong. I don't see instructions generated. Right after we print this, we should call this, right? Did I not save main? Didn't save main. Save your files, kids. Save your files, kids. All right. Hey, okay. So, well, this is why it's a good idea to profile. Look at all these. Yeah, debug current statement is pretty far up there, which that bothers me a little bit. Wow, assigned a function pointer 10? Really? Oh, because when we call it, I don't know, man. Okay. Oh, and this isn't, there'll be multiple lines by type, right? Obviously. Let's just look at line. Well, no, let's run this on Sokoban. This is what we're really curious about, because that's mostly just the preload. What we really want to know is this. Okay, so 30,000 is poke argument, which is how we put an argument into a procedure call. Wow, really? I guess we have 14,528 different procedure calls. Because there's one of these for each. So basically, in bytecode, when we're going to call a procedure, we make a calling record, we put stuff into it, and then release the calling record. And, you know, like on an actual backend, release calling record doesn't do anything in terms of generating code, right? Because this isn't like some Lispy language, but it's used for internally tracking stuff. Where's that debug instruction? Oh, they're all broken up, right? Because they're from different lines. Now, there's a little bit of flaws with the way I'm doing this right now. Okay, so this is the set of instructions generated by location, right? But we can also make okay, we're going to have two outputs. So this tells us which locations are hogging the most code. And we're also now going to output which instructions represent most of the code. Because you want to know that too, because you might have some code in your bytecode emitter that like has an if else, and it's all for the same case, but it's slightly different variants of the same case. And because those are different line numbers, they'll show up as different places here. Like, hey, here's a bunch of returns. So yeah. So we're going to do another thing. We're going to say very similar to what we just did. I'm not going to rename infos to something more specific. This is going to be called infos by instruction, and that's going to be bytecode count. Okay, so we're just going to clear it all out to 0, and then we're going to go back over the source data here again, and we're going to say infos by instruction sub I. Can you tell that I'm, oh no, sub, I'm getting tired, guys. My sleep's been weird. So we're going to pull the instruction out. We're going to subscript this by instruction, right? So we get that info, and we say we're not going to write line numbers. We're going to say info.count plus equals count, right? So whereas before we were adding into an array, here we've got it set to a current size and we're just accumulating, right? And then we'll Q-sort these again. I suppose I could have just done it off this infos array because it's shorter. Much shorter. Okay, so now we're going to do something different. We're going to Q-sort that, and then we're going to say if so this one was we'll call this instructions generated by type. And we're not going to print the line number. It's just like that. Okay, what did we get wrong? Same thing we always get wrong. Isn't debug generation instruction only recording one instruction per source line? No, it is recording many instructions per source line. Every time that line of source generates an instruction, it adds one into that slot. Hope I didn't make a dumb crash with all this, how long this has taken. Oh, I did! Wait, really? We might have to run that in the debugger. Oh, I'm doing the wrong thing. This should not be infos. This should be infos by instruction. What line was our assert? Line 1? Oh, it doesn't tell us. By instruction. We use the same compare function. I feel like that's still not going to solve our problem. Let's run it on the simple. All right, well, can I successfully go into a debugger from here? No, fucking window, like, why are you doing that if you're not going to let me do that? Okay, we're going to run simple if. So what's happening is we're subscripting an array out of bounds, and either I did something really dumb or something unexpected is happening. All right. How is it 0? that should... Oh, it's the wrong array again. This totally wouldn't have happened if I put this in a separate procedure. But really, I want to be able to say like dscope infos here to make sure that I don't use it anymore. But I can't do that in C++. Can't do it in my language either, but maybe someday soon. Okay, what was the friggin' problem? Oh, is this right here? Hope someone in chat caught that. I'm actually drinking black tea right now, but I do have green tea at my disposal. Okay, so this is by type. Why is unused binop struct dereference a frickin' thing? I don't even know. Well, it probably doesn't matter. It's probably not here. Let's see. Okay, procedure arguments. Assigning to constants. Dereference register plus constant. Calling records. So as long as we stay with this way of doing procedures, we're always going to have at least these 45,000 instructions. That gives us kind of a lower bound. Not really. I mean, the lower bound is much higher than that. But that's interesting because we're at 230. 45 is about 20% of that. You know, so it's like, it's not like we're generating an order of magnitude of waste here. Yeah. This might be the place to stop today because I'm going to dinner eventually, and I don't think I have enough time to start being actionable on this. We can just sort of think about it a little bit. Let me get a... I'm going to put that in a thing so we can look at both sides at the same time. And before we get fancy with that, let's make sure that the tests still build. Like I didn't screw something up for everybody else. They all work. All right. So we're going to go text. I don't know why that happened. Okay, so by location, and then, yeah. Whoa, we printed out our temporary storage in the middle of that. Good thing it happened later, so we don't care much. Okay, poke argument always gets generated in one place, so that's fine. This is always the time when you're like, oh, I've got all this information. Now what do I do with it? I don't know. I feel like this is really a lot. I mean, it's not going to impact our instruction generation a lot, but how do we have 4,000 assignments to string literals? Is that really a thing? How is that even a thing? this is where you just start looking for anomalies and you're like, why are we doing that? And then sometimes it's legit and you're like, oh yeah, I didn't think of that. And then you just learn more about your system. And sometimes you're like, why is that? And it turns out to be a serious bug. Yeah, like why are we assigning so damn many string literals? Actually, too, that's just one site. So where is that here? String literal. Okay, well, it's only one site. Okay, so this probably isn't going to decrease unless we totally change the way we're calling procedures, but I'm not sure if that helps. I mean, maybe. These probably won't change. These we could probably do something about. These we could definitely do something about. I don't know. I don't know. It's unclear. The next step is just starting to investigate some of these things. So assigned a big constant. Well, most of that happens here. Actually, let's check out the string literal. No, let's check out, no, because we know where that is in the code. Let's check out assigned a big constant. So one of those is line 4540. So where is this? Oh, it's just when there's a literal. Like any number literal, we assign to a constant, to a register. Now, of course, that's something that in many cases we could fold into other instructions. Like if you say +1, we could make an instruction that says add constant rather than emitting into a register and then adding it. But that's not the level of thing that I want to do yet. That's a little bit further along in terms of complexity. Okay, so what's the other one? Assigned to big constant. Now that said, if assigned to string literal is happening too many times, maybe this is happening way more times than the number of constants we have. Like 18,000 assigned to constants in a 70,000 line program where that 70,000 lines includes blanks. I don't know, man. I don't know. Okay. I feel like that might be legit or it might be inflated for some reason. Okay, so assign to big constant, line 701 and 694. Right, 701 is here, and 694 is here. So emit code for source location. Okay, that's those source code location things. That's probably a lot of the string literals. Oh, maybe not. No. Oh, shit. Yeah, this definitely, we're making a new literal every time? I bet we could optimize this right here, because this is happening, you know, we know 1,700 times. I don't think it'll reduce the number of instructions. let me just go. Okay, so we don't have a literal on here, but we could. Okay, that's not really what that's not going to reduce the number of instructions. It just means we don't have to allocate all these extra literals. Although it may also mean, because we're making all these literals, they have to be string deduplicated later, so we would ease up the amount of CPU time we spend string deduplicating. Okay. Right, so we're just making a constant for the line number and the character number. Stuff like this. So we're putting this into a register and we're storing that register through something else. We could make an instruction, if there seems to be enough use for it, that's just store constant through register plus offset, right? So, well, what were we looking at? Yeah, assigned a big constant. Oh shoot, I deleted a line or two. Oh, I typed a comment. So now my lines are all off by like 5 lines. So this is array bounds check. So we're putting the array dimension into a numeric register and then doing this dereference. Yeah. Wait. Bounds register. Array register gets the result. Is it? The order of these arguments is weird. Okay, I'm not sure I understand that. And then we have our own instruction. Oh, this is in. Oh no, sorry, this is the result. Usually there. Yeah, it's A, B, result. Okay, so register, bounds offset. What? Oh, that's if it's a dynamic array, we're reading the length of the array out. Got it. Yeah, I mean, we could avoid doing this if we have array bounds check constant versus array bounds check non-constant. But again, you know, that only saves us, I don't know, some percentage of 789. It's not a very big gain. And then any more assigned to big constants that we get are way down there. So really, the big assigned to big constant is this line 4540, which is about literals. Which, you know, usually would be solved by detecting the literal earlier and emitting some instruction that's like, oh, this is plus a constant. But I would have to audit all the places that do this and know how much complexity it would add to do that kind of a thing. So looking at this, I'm not actually sure. I actually want to know how many of these. So these debug statements are pop block and current statement are okay, 1180 each. So that's 2,300 instructions, or it's about 1%. So I'm not going to kill myself over that. 1% is not awful. I feel like there's much bigger headway to make than 1% here. But I don't know. I was expecting something to stare me in the face. Part of this assigned to big constant could come, because remember I started this stream talking about coercion to Boolean. Well, let me see. We have this emit code to cast for bool, to bool, right? If you're a string, we do all these things, right? So like if it's a constant, we do this cast to bool and we generate code for that constant that would do this, right? So if I wanted to audit this in a more complex way later, I could somehow add some counting for how many of these are in a subtree of the program from here, you know? And then I would know what kind of impact the casting to bool has on instruction counts. Although maybe it's not that simple. Yeah, I don't know. I just need to meditate on this for a while. I don't know what to do. It's a lengthy investigation. It's a lengthy investigation. So I feel like a lot of these are spurious. A lot of these are spurious. What the hell? We want to be able to return assignment. For typer. Right, but why are we generating that? It's the only place we call it. Make sure we're not using this somehow. Yeah. Well, we're emitting that, so we're going to get an instruction gain today, even though I didn't expect to. All right. So I'm looking for the place where we where do left register and right register happen? Okay. What is it called? If operator type is equal to return right register. I think that's correct. Let's see if Sokoban works with that. It appears to. It is a new binary. Let's go to tests. Okay, let's run the debug build on Sokoban. See how many instructions we saved. We know how many instructions we should have saved. Like 10,000 and whatever, right? 10,622. So we should get 229,799 minus 10,622, and maybe minus a little more because we like returned early. So let's see. Debug. Still 229,799. What? Unused bin op struct dereference. Oh, you know what? What? I don't think operator type can change. All right, so screw it. We're playing hardball here. Sir, inst is not equal to this. Like what? This is one of those times when it's totally Twilight Zone. You're just like, how did that not do a thing? How did that just not do a thing? All right. Well, let's see what happens if I do this. We don't care about that breakpoint anymore. Didn't assert. What? Something is not adding up. It didn't assert. Oh, there's other people generating it from different locations. Wait, what? That's not a line number from our current. So that's freshly compiled. Three, 3, 6, 5. Debug current state. Oh, do those have the same number? That's a bug. Respecialize, print register, push lexical, pop lexical, debug current statement, unused bin op, struct dereference. What the hell? Maybe we weren't ever generating bin op struct dereference. Maybe our printout is... Okay, we know that these are not value equal, not only because they're in an enum together, but because our assert is not going off. Which means our reporter is wrong. Why would our reporter be wrong? Is it because it's the last instruction? Or the last one in the enum? Why would that matter? We should have enough space. What the hell? Okay, let's look at, are there other ones? Line 1979. Debug current statement. What? What? You people are crazy. Well, this is no longer what I thought it was. Not info dot, info arrow. No, here it's info dot. Dude, I don't know. I just don't know what to think. This is weird. Okay. This is just a garbage at this point. Is the name array just out of sync? Because other people besides me added things to the name array. sometimes you just have to sometimes when you have no idea what's going on and you have to leave for dinner soon, there is one off, one screen up. Stallable. Oh my God. That, okay. Thanks for spotting that. Stallable was added by me, by the way. Yeah. See, C++ does not check for you that these match. I guess I could let these arrays vary in size and do like a static assert if I could figure out how the hell you can do that in C++ template craziness. Thanks for spotting that. I would have spotted it with this other thing, I think, just now, but saved a little bit. Let's get rid of these because these are not going to be necessary. All right, well, that means I can get rid of my unused struct dereference stuff. Let's just do this again, and we'll get ready to run Sokoban back to output. Okay. Good. We found a problem. It was not the problem we were looking for. We found a problem. We gained more knowledge of the... We can use the X macro trick to generate those string representations automatically. I don't remember that, and I don't care. I don't want to generate strings automatically because I want the freedom to change them if I want. Like these don't actually match. Some of these are shorter because they're easier to read. Okay. Let's go back to output.text. Why do we have control M's? It thinks we're a Unix file for some reason. Okay. Well, now we don't have that instruction, but now we see bytecode debug current statement. Okay. For 10,000. And some of these other ones, like everything below where was stallable? Yeah, so this was wrong, and these are all utility. So really only 2 instructions were wrong. Yeah, 1,700 array bounds checks. Not a lot. Okay, so now that we've reached this sanity, I'm going to get rid of some of this stuff that I added because, and then I'm going to make sure that we didn't destroy anything, and then we'll check it in. Is there any plan for a physical edition of the Witness PC? People ask us for it sometimes, and it's something we decided to do. You know, we were going to do a retail publisher initially, and I just got a bad feeling about it. So we didn't do it. Maybe someday we'll do a collector's edition or something. But, you know, for today, it's not really a thing that we're thinking about too much. Let's run our extra tests. just does that again, and then a bunch of other things. So many tests. Okay, well, that's good progress. So I think next time I'm going to go back maybe to this topic that I started with about the casting to Boolean, and I'm going to augment that profiling a little bit to see if it looks like casting to bool is generating a lot of instructions that could be eliminated. I need to think about the best way to do that, but that seems like a plausible thing to do, and then we'll see where that goes. Any on-topic questions here at the end while I figure out where I'm going to dinner? Okay. On-topic questions. On-topic questions. Oh, it's over there. Bro. Wait, where am I? Google Maps is like trying to get me to do restaurant ratings. I want directions. Oh my God. It's so terrible. I just want directions to the address that I typed in. How about if I walk? 26 minutes. I shall walk there. Yes, it's not too far. ETA for public release, when we are able to do a public release. What? Someone's saying they have a project that can make a lot of money. Well, go make a lot of money with it. Are we just doing optimizations to the intermediate form? You're talking about peephole optimizations. Yeah, this was just for the intermediate form. I discussed at the beginning of this stream what I was thinking about, and you could go look at the beginning of the VOD if you want to know. Is this game still part of a big episodic project? No, this game was never that game. That game that you're thinking of is a different game that I've never shown. Does put out less than or whatever it was do int less than int to bool? I believe so, yes. Like it always outputs a 1 byte 0 or 1. It's very strict about that. But if I can figure out a way to make code more efficient by making that less strict, then that'll be fine. And I'm sure, you know, this kind of territory that I'm talking about here is the sort of thing that like every procedural language developer does, because this is common to all of these languages. So I'm sure that many people have thought about this and come up with good solutions, and I just haven't thought about it, and or I'm not that familiar with what they have done. So, you know, you know, it'll be fine. Yeah, there is no Uber in Japan. It's very sad. I could take a taxi, but walking will be nice. Will I be coming back to stream? I want to do some streams over the next few days. It's kind of nice chilling here in Japan and programming and stuff. So um, I feel like that may happen. Yeah. Oh, the typing is loud. Sorry. I didn't realize the typing was so loud. I guess you guys mean the typing? Did I do the further speed optimizations that I planned to do a while back? Or is that not a big priority anymore? I don't know which speed optimizations you mean. One optimization that I want to do and that I might attempt on stream this week is making namespace lookup faster. That might be what I was talking about, because our compile times have gotten substantially slower now. Like Sokoban, a release build of Sokoban right now is like 1.5 seconds, whereas it used to be like 0.8 seconds or something. And well, a lot of this is the linker because we switched back to the Microsoft linker. But the front end time is like 0.7 seconds. And a lot of the reason that's so long is because OpenGL has a lot of names in it. And those all get into our global namespace. And all our namespace lookups right now are linear array lookups. And you can imagine when you have like 1,000 items in there or something, it starts to get slow to do that every time you look up a variable. So I believe back in San Francisco or somewhere, I did a little bit of a profiling and we saw that that was indeed slow, but maybe we'll do that again and look into it. Oh, the game sounds are loud. Sorry. I guess my desktop volume is up pretty high. We're not running the game now, right? There's no sounds now. There's no sounds now. Ginger Bill says, one bottleneck for my compiler was allocating for the heap stuff. Using heap alloc directly instead of malloc was so much nicer. Well, we use our own arena allocator instead of malloc, but the same outcome, right? You don't want to be calling malloc all the time, for sure. Use a prefix tree. I think we just use a hash table. I don't know why I would goof around with anything besides a hash table. Sorry, I guess is this microphone turned down in Windows? Is that why? Let me see. Recording devices. Microphone. Properties. I don't see a volume anywhere. Why is Windows so... Oh, levels. It's set to 100. Maybe my mic is just naturally quiet. Well, whatever. All right, everyone. Thanks for coming by. I'll try to do some more streams here in Japan in my theme cultural appropriation outfit here, which, by the way, the hotel left for me to wear in my room. So the hotel encourages cultural appropriation, clearly. Yeah, I'll turn down, just for the next stream, I'll turn down the desktop audio a fair bit so it's not cranked way up. All right. Thanks, everybody. I'll see you later.